Aaron,
Yep, I'm here. So
perfect. Well, that's
there
great.
we go.
Oh, perfect.
All right, no, I've done this.
Take it
I've done
away.
this a few times.
Take it away.
So actually, sorry, I've got a bit of a cold, so hopefully my voice is not too much of a distraction. So, but I'm still working, and actually, we're a small startup that's been around for a while, and I've been heavily involved in IoT for many years. As I said, Magnus and I go back a long time. So, but I'd be interested to display what we are focusing on as a company. Just a quick overview. We're not providing hardware or anything like this. We're actually a pure software or platform company. And we basically took on a challenge that I think most people said, you must be crazy to take on this challenge. And the idea was that we had a belief that resource-constrained microcontrollers had the right to have some form of lifecycle management. And what that means is, not just about writing software for a low-powered microcontroller and throwing it out there and saying, it's due for the bin in a couple of months or weeks, but actually say, what about providing a real lifecycle management platform for the whole lifecycle of the device, specifically around provisioning, deploying, doing firmware updates, and eventually decommissioning the devices. And we've seen platforms exist for this. I think probably the most notable one was Pelion, that exists basically for the high-end ARM-based microcontrollers. But do you see something like this exist for an AVR or for a PIC18 or even a Busy Bee from Silicon Labs? And the answer is no. And for some insane reason, I decided to take on this challenge. And that was about 5 years ago. We started the company, and we actually have delivered it. But at that being said, it actually developing for IoT it has evolved over the years. And I think an important thing that's kind of to identify is, you have to kind of think how do developers deal with developing, what are the challenges? So, from a developer point of view, the easy part, and this is what everyone wants to focus on, is the thing, right? So you have a basic microcontroller, you have all your sensors, you have your actuators, you do all your logic, you write your machine learning code, you do your if this, then that, you interface with all the sensors, and you get all this data. And that's the stuff that I think when people say, I want to work with IoT, they think this is where they're going to spend 95% of their time. But the reality is the hard part of IoT is actually network communication, security and privacy, establishing root of trust, having a robust environment, having layers in place for data protection. And like I said before, the whole principle of lifecycle management for delivering firmware over the air. So this is what we see as the easy part and the hard part. And what we do as a company is we actually said, why don't we try and provide a platform or a service for developers so they can focus on the easy stuff, and we do the hard part for them. So that's basically what we've developed over the last 5 years. And the bottom line is that developing for IoT is actually hard, right? I have a lot of presentations that I could spend hours talking to you guys about that go into all the details of nightmares of open source projects, etc., and dealing with the 1% chance of something going wrong. That does happen, and every IoT developer deals with it. And the reality is IoT development is actually hard. So one thing that Rob Tiffany, who was a former VP of Ericsson, he actually said that with IoT, we've created the largest attack surface in history. And what that basically means is we've basically been stupid and thrown out all these devices that have no security, default passwords, and said, look, hackers, go ahead, hack them and make them part of botnets and do whatever you want. So this is another challenge that we thought, while we're doing this, why don't we try and address this at the same time? So we have a focus on our concept of saying the Internet of disconnected things, right? And it kind of goes against the whole concept of IoT, but in reality, the only secure device is actually something that's unreachable, right? So if you can reach it, chances are someone's going to poke around and try and get in it somehow. So we've taken this concept literally and said, well, why don't we take the thing and keep that thing completely isolated from the real world, so people can focus on what they want to do without having to worry about security and everything else. So how does this kind of work? We basically say, let's say we have the thing here, which is the project you work on. Like the first presentation said, this could be your machine learning, accessing sensors, doing all your machine learning on the edge. And what actually happens is we have a separate microcontroller specifically for the purpose of doing networking. then we have some form of bridge between the two, so that we can provide like a secure VPN type tunnel, so that that designated microcontroller that the customer has can communicate data back and forth. But at the same time, we have the ability to reprogram that microcontroller directly, so we can utilize in-system programming or the SWD or JTAG interfaces that exist on the microcontroller. And the great thing about this is that you get this beautiful concept of isolation and security. So you can basically tape a prototype from the desk that has no concerns about security or whatever, actually put it behind our little environment, and it's a fully commercial and feasible device that will never get hacked. Right? So basically, we provide that little sandbox environment, but not just a sandbox in terms of a virtualization environment. I prefer to say it's more of a hardware virtualization. So you actually have your own microcontroller in your own environment to do whatever you want with. So the key thing with this is there's no need to be a security expert or a resource constrained developer. You have freedom of choice. You can run completely isolated within your own dedicated microcontroller. You can run your own operating system. You can run your own programming language, your own runtime environment, use whatever frameworks and libraries you want. And to give that a comparison to what's out there on the market for example, Pelion, is that they kind of say, we share the same CPU. You have to write your code in C or C++. You have to share the CPU resources with our library that does all the lifecycle management and everything else. So what you end up doing is you end up fighting for the processor time. And the idea of what we've done is by doing a separation of concerns, we kind of say, we do the networking, you do what you want. You have complete freedom to do whatever you want in whatever environment, whatever language. Basically, from our point of view, we say, if you give us a hex file, we can flash that microcontroller and then reboot it and do whatever you want. And if you screw it up, we can still reprogram it and restore it to a healthy environment. So that we've taken the challenges of actually dealing with security, communication, robustness, and keeping your systems alive away from the developer. So I mean, it sounds like a crazy idea, but we actually have pulled it off. And I think I could have gone and done 50 presentation slides. I've got presentations going back to the last 5 years, but I think key thing here is the proof in the pudding. I've been working on a project with SAS. Everyone knows SAS in Sweden. That's Scandinavian Airlines. And there's been an asset tracking solution that's been in constant development since 2010, which I've actually been actively involved in. It originally started off as a series of modems like Infora modems or Novatel wireless modems that just had a 3G modem that had a couple of sensors. And basically it was a very limited environment, and it eventually expanded such we wanted to have more processing. So we threw in an Arduino Mega for the sake of it. And then as by doing that, we could add more sensors and do like different boxes of battery monitoring, so forth and so forth. But then we found the challenges of saying, by being tied to these modems, we were kind of saying, well, how do we do firmware updates? How do we change the concept of reprogramming a geofence boundary and so forth? So we in the first couple of years, we used to bring the vehicles off the tarmac, open up the box, stick a USB cable in, reprogram the firmware, and it would cost around €1,000 per device to do a firmware update. And obviously, if you just had basic logic that you never really had to change the firmware for, it wouldn't really matter. But when you start doing geofence boundaries, and if anyone's been to Arlanda the last 5 years, you would see that Swedavia has done a ton of reworking, digging up the tarmac and moving this building to that building and so forth. So they obviously have a requirement to deal with different geofence zones and so forth. So what we've done over the years is we built our platform specifically in mind with this customer in mind. But of course, it's not a solution specifically for SAS. It actually can be used in any environment at all. We've got that old 80-20 mindset to say we do 80% of the concept, which is our product, and 20% is customization. But the great thing with this is that we can now we've replaced all those, or in the process of replacing those devices with a new device that uses our modem basically, which is a telematics device, which is, in this case, it's an NB-IoT or a LTE-M module. We had it running on a pilot for 2 years using a 3G module, but with a 3G sunset, we're actually in the process right now of retrofitting the old legacy system with our system. And what I can do to demonstrate this is the best of all worlds is live demos. So we're actually in the process of deploying vehicles. So, you know, we have 16 vehicles. We started last week, and here they are. Here they are on the tarmac. Let me move that out of the way. If I do zoom in, we can kind of see these are the gates. So anyone who's flown at Alana, you know, the F-35 gates and so forth. And these are actually vehicles and that are sitting on the tarmac. And this green one here is actually one that's been turned on. These vehicles, the 6,000 vehicles, are actually de-icing equipment that's just been installed today. So they're the ones that go to the planes and spray all that anti-icing stuff on the wings. But these little devices here are actually what they call Linde trucks. And they're the little guys that actually drag your baggage around the airport. And basically, to give you an idea of how this looks in a larger scale, this is just the deployment as it stands from our point of view today. I can show you the existing deployment very, very quickly. And this is the integrator that we're working with. And this is their complete environment. If I want to turn on every single environment, I can turn on every vehicle. And you see there's devices everywhere, right? So basically, today we've actually been taking system devices out of their system and actually putting them in ours. But as a result, we've actually put, today, we just had an integration to say whatever we took out, we're putting back. So you can see here, this is a baggage truck, the 9873, which is in the baggage area. If we look at our other console, it's actually down there. So it's in the same place. So we're actually doing a migration, and actually a migration from, but also a migration back into, because obviously this solution here is more of a workflow management that SAS has internally for its ground service vehicles. But our focus is actually on the telematics of the devices. And the key thing with this is that I can take any of these vehicles and you think, okay, that's nice. We have a modem firmware, which we can change. But the key thing for us is actually an application firmware. And the application firmware from SAS's point of view is to say, every vehicle must have a badge swipe in order for someone to drive the vehicle. And they have geofence zones. And these zones are going to be updated. And it's not just a case of saying, let's go to our website and download zones. We can actually deploy a firmware that contains all the information inside them in a simple click. So I can just go to one of these devices and I just open one here. You can see this is the basic firmware for the modem. So I can change that if I wanted to. But more importantly, this is the little microcontroller that is actually fully owned, and the code is written, the responsibility of the customer. And we can change it from the badge swipe to back to factory, just basically erase the firmware, or I can just say, turn it to a blink. And what will happen, you'll see what happens. Hopefully this thing talks for the next minute or so. So it talks once a minute, and actually we'll see this change, so that the firmware has gone from 1.000 to 0.001, and it all just magically occurs, and it's click, 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 and no more USB cables, no more visiting the airport. I could do this here. Probably won't do the firmware download. Oh, the ignition's off, so it does know when it can do a download, but we should see it come live. And you know, the demo guard's always on my side, so 25:58, so maybe at 27 there's a communication. So we've got a couple of seconds, and hopefully we'll see it do its business and say, thank you, I've done the firmware update. So there we go. We just saw it happen. So now we've seen that the firmware has gone back to a basic blinking firmware. So now that anyone can jump in that vehicle and no longer have to require the badge to swipe. So I probably should put that back before SAS gets mad at me. And it's as simple as that. So this is how we can do firmware over the air. You saw in that same pull down, I can actually say, go back to factory, and that basically erases the firmware that's on that microcontroller.
Perfect.
And we can do this. I'm doing this from my lounge room, and there's all these vehicles running around in our lander. I can do whatever I want from remotely, of course. So probably not a good thing, but luckily I have all the secure passwords and everything. So, so with that, live demo is always good, as I said. And then we can go back, and these are our contact details. I guess you're going to ask the same questions there, Magnus. Where are we in investment rounds and everything else?
Yeah, that would be my idea.
So I might as well jump in and tell you where we are with that. And basically, we're still 100% owned by private. Myself and Björn are the two founders of the company. We actually have survived COVID with the luck of being involved in an EIT digital project, which is actually the ones who helped sponsor the pilot of this with SAS, but we've also had a couple of pilots in Italy with Kamau, who was a car manufacturer of robotics. But basically, we're actually still 100% privately owned. We did try to seek investment in the early years, but I think it was too early for us. I think a lot of the investors said, "Where's your customers?" So right now we're about 5 years old, just over 5 years old, and we're in the process of actually putting together. Once we get this deployment successful and everything's up and running well, then of course we're looking to expand. Not only just expand to say let's go to different markets. We can do anything from, this happens to be in the aviation industry, but there's nothing stopping us from doing this with farming or utilities or even smart cities. The idea would then be to expand and obviously look for investment. So the exact details of what we're looking at in terms of investment, we haven't kind of nutted out yet, because our focus right now is to, of course, get this deployment completely successful. And of course, once we have that customer use case, it makes it a lot easier for us to talk to investors and so forth.
Great. Thank you, Aaron. Thank you. If there's anybody I know who could actually take on this challenge and actually deliver, it would be you. So I'm so happy to.
I'm being nuts. 5 years I've been doing this.
Aaron, I have a question for you in the chat here. So if you want separation, what is the alternative?
If you don't want separation.
If you want separation, what is
we do have separation. That's the whole point.
Yeah.
So the idea with us is,
I turn on the mic.
Yeah, sure.
If you want to have separation, what is the alternative to using RIoT solution?
What alternatives exist?
Yes.
Nothing. There's absolutely nothing on the market right now.
Yeah.
And we've seen potentially people think about the idea, but no one's really taking it seriously.
Okay, what about Linux?
Well, okay, I wasn't sure I was going to go into this and start discussing let's put a target on our IoT devices.
But we don't really have time for
Yes.
that. I will be more than happy to introduce you to John afterwards if you like.
Oh, I know John. I know who this is.
But let's stop there, because we have to jump on to our next speaker. But thank you so much, Aaron, and good luck onwards.